Sandy, I think if you sit here,
Okay.
Joe could be there, Brett,
Okay.
Susan, and I guess I'm down there. Oh, I'm down there. Okay.
Yeah. I love beats. Awesome. Beats are awesome.
Oh, and beats too. Oh, yeah.
Thank you.
That's yours. Good.
Oh, yeah, we've had some where you put the potatoes and then put the stew over the potatoes.
It's really good. Help yourself.
Oh, yeah, that too. Yeah, that's a good idea.
Give it a try. See what you think.
Having this agreement contract signed with the university on Monday or Tuesday, right? Hopefully. It might be a bit of back and forth.
Yeah.
Well, and then Brett gets to go into the university and get an office and start working on the project. But so the theory, it's kind of like people might know string theory. Have you heard of string theory?
I have.
Yeah. So it's not string theory, but this is kind of what we're shooting for, is to introduce a new theory.
Yeah, it's kind of like a low energy effective string theory that you can see a lot easier. You know how it leads to like the standard model and beyond, and all other unsolved problems. You know, the cosmology in 6 dimensions. You know, and then it's also kind of dual to the effective particle theory and. You know, so the small scale that leads to the big scale. And,
So would that unify the two?
Yeah, especially because like on the micro scale, like it can lead to like actually finding the extra dimensions since they're smaller, and then on the large scale, so then it can lead to the dark energy or dark matter, and you know, which is 97% of everything that nobody knows.
Yeah, okay. I'm still looking for it.
So, yeah, so they're all kind of tied, like the big and the small. Yeah, they're all kind of.
So, Brett, if I understand you, the extra dimensions will tie the two together. Cool. Good.
Yeah. So the to summarize it, it's that we're hoping to add 2 more dimensions to time, or more dimensions than that. But for me, it's staying focused on the two extra dimensions.
Yeah.
So then you have a total of 6 dimensions, because there's 4 dimensions. In our conventional 4 dimensions, we have length, width, and height, which is 3 spatial dimensions, and then you have an arrow of time. And so then, if we go toward the symmetrical space-time, so you have the 3 space, and we want to put 3 time in there. 3 time dimensions. So it can be, you might want to visualize it, you could visualize it just like the arrow of time, and the arrow of time can rotate right or rotate left. Now that's not mathematical physics. We don't know what the 2 time dimensions look like, but we really want to check out the math. So all we know right now is, let's take the math of 6 dimensions. And Brett has already applied it to biology, to chemistry, and to physics.
So you can join those.
Yeah, so you just use a different math to interpret everything.
Yeah.
And Brett's done an amazing job, and there's a book almost of 300 pages or more of how the math has been applied. The alternate approach to interpreting reality has been.
Gotcha,
yeah. So if you have to apply it to all these different subjects, and you get enhanced predictive power, so you can predict something that you haven't predicted before.
I like that. Okay, good.
So that's a test of good theory.
Yeah.
And then, if you can test it and we can experimentally verify it, then that's wonderful.
Yeah.
So that's kind of what we're shooting towards long term. Yeah. So the next year is really going to be about inviting the peers and the community into it.
Yeah.
And see what happens. It's very exciting.
Yeah, it'd be interesting to see their response. They might come up with a good question or a good lead to go somewhere else.
Well, change is hard, any type of change, and I think we're going to be faced with, and especially Brad, I think, during his seminars and these lectures that we hope to put on, because change is hard, that there will be a lot of tough questions and people won't want to change. But as such, that's just how it works. So
even then, it's not a change. You know, it's an addition, so it's not a change.
Right. Yeah.
Okay. Gotcha.
And it's better than string theory. So you know, like people should be more critical about string theory.
Yeah.
Yeah. So, Brent, when you're saying it's addition, you mean like a next step sort of thing?
Yeah, so
Or
it's
is
like
it-
it stands on top of the giants.
Okay.
Or is it a paradigm shift?
No, I wouldn't say a paradigm shift. No. Yeah, it should be something easily acceptable. Just immediately.
Okay. Got it.
Oh, well, there you go. Some confidence.
No, that's good.
But like it's just obvious.
Yeah.
You know, there's no questions to ask.
Incremental change is easier than a complete paradigm shift. So,
Yeah.
But like sometimes, you know, like there might be like it's like a paradigm shift, you know, like from classical to quantum, like you know, it still was just a specification or a subset of classical physics, and same thing with relativity. So you know, it's just you know, like what happens at the extremes, you know, like low and high energies, and yeah. So it's only like a paradigm shift, you know, in a particular exclusive area. Yeah, so, especially, you know, unsolved problems. And, you know, all those Millennium Prizes and
Yeah, the Millennium Prizes, I think there's 10 unanswered math questions, or maybe 9. Someone answered one, but and if you answer these 10 Millennium, then you get $1 million for each question if you answer.
oh, is that right?
Something like that, yeah.
Does this answer one of them?
it tries to answer all of them.
Oh, it tries to
Oh, I
answer
think
all
that
of
would be brilliant. Wouldn't that be brilliant? Oh, wow.
Yeah. We have to, because if you accept the 2 extra dimensions, then you have another variable basically to play with.
them. So you said that you've already seen how it works in biology. Is that right?
Yeah,
Did
like
I
especially
understand?
like how like the fractal structure of nature, and and how it emerges from 6-dimensional projections, and a lot of life forms and all that. Yeah, are projections from simple inanimate structures in 6D, and so in 6D there is no life, but once you take those extra 2 dimensions of chaos out of it, so you integrate them out, then you create life. So it, you know, so it takes those 2 extra time variables to create life.
Yeah.
So,
So there's in biology, there's something called Newton's laws of biology. Someone coined that. These are Kleber's laws, and you can predict how long you live based on your heartbeats or your metabolism and or your size and weight and so on and so forth. There's patterns in biology,
right.
and so just like there's geometric patterns in the world. So what Brett I think is trying to say is that you have if you have a 6-dimensional spacetime and you project it and you take away the 2, then you end with 4 dimensions. So it's like shining a flashlight through, just because that's maybe an analogy you can understand. If you shine a flashlight through the 4 dimensions and just shine shine a flashlight through the 6 dimensions, and then you only see the 4, so you take the 2 dimensions away.
Yes, it's like a shadow on a wall.
Yeah, thank you.
You're going from
Yeah.
3 to 2, and then this is 6 to 4.
Yeah, so the shadow is the 4-dimensional world. And in the 4-dimensional world, you see patterns, you see geometry, you see life. And so those things can be projected from this more fundamental structure,
Gotcha. Yeah.
mathematical structure that Brett and I are talking about. So it gives you another way to understand the natural world and to connect everything. So, for example, one of the things that if you do this shadow, you can project the golden ratio, which is a notable ratio in geometry of life, but not the silver ratio. Is that right?
No, it's both.
Oh, is it? Okay.
Yeah, because it all depends on the angle that you project, so you get every number that you want. But the golden ratio is the most common because it's more stable, you know, like in that landscape.
Okay.
Yeah.
Yeah, so it comes back to just projecting the shadow world is the one that we live in, because humans don't really pick up on these 2 extra time dimensions. But if you look at the 6-dimensional space-time, it almost is more simplified. Is that a fair statement?
No,
Yeah.
So, for me, who is not a physicist, what does this mean for my understanding of the world?
it's like more like how. Well, I guess I'd say that to see the world, it's more as a like how it actually is kind of like a projection. So at least most areas of in life are are kind of more deterministic than you think, but in a way, when you like, so two extra time dimensions, those are dimensions of chaos, whereas dimensions of space are dimensions of order, and so you get 3 and 3, so it's the perfect balance, for a dialectical world, and so you need that balance, and yeah, with the two extra dimensions of chaos, then you can get life from those, and and it takes more than one extra time dimension, because you also have to have a soul that like cellular automatons don't.
Yeah, so it's for me. I think that's I agree with all that.
As an example.
Yeah, I think for me it's really interesting to take that thought one step further and say, so if you can kind of calculate more about the world, if it's more deterministic, then you go back. So calculate more, meaning that if you have a supercomputer, could you make this reality? If you have a different code, and so there's an argument that it's more deterministic.
What does that mean to say it's more deterministic? Is it a deterministic opposite to chaos?
In a way, yeah. Like if it's deterministic, then it's black noise. So whereas total chaos is white noise, and so black noise is just it's like a direct current signal, as opposed to a signal that contains all frequencies, and all, so it's pure chaos, and yeah, so deterministic, it's fate, so Einstein was all for that, he says that God doesn't roll dice.
Yeah.
But
so
he never liked quantum mechanics, but then quantum mechanics, it's related to the emergence of chaos, and that can all emerge, from just projecting out an extra time dimension.
Yeah, so this uncertainty that we have in the future, that we can't predict the future, is something that Einstein seemed to not like.
He didn't like that.
No, it didn't feel right to him, I guess, right? So he believed that God does not roll dice, so which means deterministic. So in your life, in our immediate life, the argument between determinism and free will is in the court system. So if you go and someone, I think there's a court case here at the Mount Royal University where someone misbehaved when he was on drugs. So does he get off for the behavior? Because was his behavior of his free will, or was he determined in his behavior? And so all of the criminology and the court system, there's this fundamental argument that is not been addressed properly, which is, are people determined to do what they do, or is their choice, is their free will? And so it's a big philosophical argument. So this math and this projection really underlines the determinism side of that argument. Because if you can predict everything, you can show mathematically that you can. You can show how in biology and behavior, it's more fundamentally underlined by math. Then it really argues towards determinism and not free will. But that's all good and scary and everything. But I think for me, when I'm going through all these projects and the project notes, what happens is the more you get involved in the science and the math, and the more you focus on it, and the deeper you go, it takes you back, all the way back to, there's something we don't know. Is there a God? Is there so on and so forth? Is there something beyond all the math? And beyond all the determinism, there's something there. And that's the really exciting part of it for me, is that, yeah, you can say that things are projected and determined, but what's behind all the math still? Why is it even there? And so I think it argues strongly for soul and consciousness and something beyond. So it's really fun. So the math is just this hint at something bigger, this bigger argument, almost religious argument, between determinism, free will, and God and consciousness. And it's really fantastic. So this whole next year is going to be a blast because, once Brett and hopefully a whole bunch of people supporting Brett will really sculpt this theory. And it's a theory of determinism, really, but there's this thing behind all that, and it's a religious and philosophical and spiritual.
Yeah.
And that's the best part about it.
Yeah, but isn't that down the road? Because next year, I'm thinking you're really going to spend time on the core of the theory. And then what you're talking about would be after that.
Yeah. Oh, yeah. It's a long road for sure.
And then there's like the like proposing experiments, in that, and and they have like some like with Dr. Barkley there, he has some nanophotonic stuff, as you mentioned there, and that could be used. We can use that, in the Casimir effect, in detecting like extra dimensions or through other.
So have the two of you thought of any potential experiments that are hopefully easy to do that would kind of corroborate what you're doing? Or?
Well, I guess it kind of seems like, well, like with the nanophotonics lab, it could be good because it can test for like effective QEDs, so quantum electrodynamics. Just out of the vacuum, out of nothing, and you can kind of see how that is related to extra time dimensions.
So would they have the equipment at UFC to measure those sorts of things?
Yeah, since they have like all the nanofabrication, and they are able to do like a lot of the experiments that are like sensitive to the Casimir effect, and it can be used.
So they'd have equipment for it. You could set up a Casimir effect experiment. And
We might have to build slightly more sensitive equipment for the one experiment. But,
well, I guess it depends, as far as you want. Like, because you could either like it would have to be more sensitive if we just looked for like a change in the power law of the attraction between two plates, say, from like nothing, they're just neutral or conducting plates, and see like at a smaller scale does it change, but then other forces come into play, like there's inverse 12 forces, inverse 6 forces from induced dipoles and from the van der Waals force, and then there's thermal forces, and then there's the supersymmetric Casimir effect, and so it can be repulsive, it can be attractive, and it can change as you go at different distances.
It's not just gravity. There's something
and then you have to look at all the background on it. So there's like 12 effects you have to subtract, and then find out what the epsilon is.
Good times.
And, but then for other things you wouldn't need as much sensitive equipment if you were just looking to see like kind of looking at low energy quantum electrodynamics and that in the nanophotonics, and so it's also kind of the dynamical Casimir effect can help with that, since the photon creation rate, it depends on the extra dimensions, and those are easier to measure than a force.
I didn't mean to get too much in Casimir. I was just thinking it would be nice if you had 2 or 3 ideas that were not as complex as Casimir, just nice, easy I know that.
I think they're gonna emerge with time. Like when peer review, you get all these different collaborators coming in and questioning. I think there's some ideas that will percolate and kind of take center stage.
Yeah.
But I think the main
because
argument.
there's still like like some like a lot of open problems that are kind of explained, not proven, but at least explained with 6 dimensions, because they have what the G-2 experiment where, it's like, why isn't it G-2? Why is it, just a, tiny, like a trillionth of a trillionth of a trillionth of a trillionth of a trillionth, off, and all things like that are important. But those are done, at larger facilities.
Yeah. Well, that's the thing. I mean, why did they build the CERN particle collider? Why did all the countries come together and put all these billions of dollars together?
I don't know, but they had a lot of money.
They had a lot of money, but I think so. With Brett and I, my argument is that okay, we'll prove if our theory here is kind of like semi-reasonable, and we get out and get peer review.
Yeah.
Well, I mean, really, all we need is a little bit of money to check.
Yeah.
Instead of billions and billions,
Yeah.
they give us a more of a hint at what fundamentally is going on.
Yeah.
So there's somebody out there and a group of people that think it's very important because they put so much money into CERN.
Yeah.
Yeah, and I think we can design an experiment for a lot less money than that to really prove beyond a shadow of a doubt there's extra time dimensions.
Yeah. Maybe they'll run it on CERN.
I don't know if they can. Well, they could do the heavy Higgs particle is what you thought might work there, but
Well, I think now they're just more looking directly for the extra dimensions now. So
are they?
So that's the next step.
Yeah.
Yeah, you might get some ideas from Holden as well.
Although,
You
yeah,
might have a few suggestions. But,
yeah. Dr.
Well,
Holden, he's not committed to 6. He thinks that there's potentially extra dimensions. I'm
Well,
not
of
sure.
course, like 6 is still it's the effective field theory of a general string theory, but it's the most effective.
Right, and so
For
I
what
think
it does.
my argument. So Dr. Hobel thinks like he's keeping his mind open. He's saying, okay, maybe there's instead of 2, there's 3, or there's 1, or there's some extra dimensions out there.
As any scientist should.
As any scientist
Sure.
Yeah, but for me, I think that if you go back to 6 and you go to the symmetrical spacetime, it really makes sense in a lot of different fields, right? So it's cross-discipline kind of argument. So if you go away from physics and mathematical physics, it doesn't make sense over here in biology, it doesn't make sense in chemistry, it doesn't make sense in philosophy.
Well, I think you're saying it does, and that's part of what you're going to be doing.
I think that's a strong argument why 6 dimensions would fit better than, a different one. Is that it makes sense from a lot of different perspectives.
Yeah. Okay.
Yeah, it's a lot more it's more phenomenological and applicable and pedagogical than string theory, which its landscape of vacua is way too large to for even AI to navigate. But in 6 like we can have it all written down. But even then, it's still it won't lead to determinism. It's deterministic to God. In the bulk space. So we live on a brain. A 4-dimensional brain floating in 6-dimensional space, but the 6-dimensional observer sees everything as deterministic, but people on the brain don't.
Yeah. So there's still be free will. Yeah. The conversation. Of free will.
It's just that. Yeah. The God in the extra dimensions, knows everything, and that's immediately from determinism that is there.
Yeah.
So if I'm understanding this, you're saying if left unattended, determinism wins, but you can use
but we'll never know
intention to overcome it. Is that
No, I don't think so.
No?
Yeah.
And it's wonder. It's wonder because still because from the projection, like there's always like some forces, that can cause you to make choices, but it's,
Yeah, randomness. It's interesting. So all
and
statistics
and convince you, that it's your free will, but
In terms of free will, it might be time for apple pie.
yeah. Oh, good call. That is.
oh, that's perfect.
So just go.
Brett, do you see these things in your mind?
Yeah.
Like, can you visualize these different ideas or theories in your head?
Yeah, like even though it's hard to visualize like 4 dimensions even, but you can still get the idea, but by just kind of thinking of it like as a like with the shadow analogy, or just a brain world analogy. So you can just draw a 4-dimensional space as a line and say it's a 4-dimensional line, and then visualize everything like that.
Yeah, I don't. Brett, the way Brett thinks is different. I'm more a visual thinker though, for sure. But I don't think we can visualize 6 dimensions. It's kind of weird.
But you can visualize what a 6-dimensional lattice looks like, and how it would project onto quasi-crystal.
Yeah.
With quasi-periodic in space and time. And all these biological evolutions.
I think we scared him away, Brett. My parents
Scissor time.
That was great. It was so fun.
Your battery's getting low.
Is it?
What would be your final word to the world? The beginning of 60.
My hope is, this is a really exciting year for Brett and I and Dr. Hobo.
Thank you.
We have a really massive adventure. I'm super excited about it and love to share it. I think that I hope my parents and other people will support Brett and support the project and share in kind of the excitement of it and the pursuit of what is life. It's so fun, and we get the opportunity to do it. It's so amazing. I'm just really excited about it. How about you? Is it next year?
Yeah, so it's the same thing, it's like a important step, to step, out of, to step into academia, it's a necessary step, in order to be peer reviewed, attend conferences, and not be judged as fringe, and it's so after this we can do anything without being it's the constructive criticism, but as opposed to just blatant ignorance.
Yeah, there's social stigmas around not being associated with a conventional institution, I guess, academia.
Yeah.
So we get in there and we get through the peer review and you get to showcase some of your knowledge. It's gonna be so fun. Yeah.
Awesome.